Alright, today we're going to talk about perpendicular bisectors, and there's 4 theorems that we need to learn and then apply. The first theorem says that if a point is on a perpendicular bisector of a segment, then it's equidistant from the endpoints of the segment. What I really want you to notice is this symbol right here. That means perpendicular to. So this reads, if line PM is perpendicular to line segment AB, and notice that there's no line segment over this, so when you say it out loud you're going to say the length. So the length of MA, line segment MA, is equal to the length of line segment MB. Notice that perpendicular, this is perpendicular because it comes down at a 90-degree angle and creates a right angle. Not only does it create one here, but it also creates one there. And perpendicular segments always create 4 90-degree angles. So we've got one here, we got one here, here, and here. They don't draw them, but they're there. And another thing is that this is marked congruent, just like it says here. When those two things happen, when you have a perpendicular bisector, then if I connected the point P to B and A, notice how they did over here, then they would be the same length. And that's what that theorem says. They said if you have a perpendicular bisector, then any point on the perpendicular bisector is equally distant from point A and point B. So if that point P was up here, let's say, and we drew a line down here, they would also be congruent to each other. Not to the originals, but you get it. So any line, any point that's on the perpendicular bisector, you could create a triangle out of it, and it would be an isosceles triangle. And the converse is also true, that if you have an isosceles triangle, like shown here, and you come down the center and create a perpendicular bisector, then you have these two equal, and then you had the outside also equal from before. Alright, the third theorem that we're going to go over is called the angle bisector theorem. And it says that if an angle bisector like QS, notice ray QS, bisects this bigger angle here, and it cuts it into 2 equal pieces, which they have marked. And if that happens, if you have a bisector, and you also have perpendicular line segments, notice it says line segment SP is perpendicular to ray QP, and line segment SR is perpendicular to ray QR. Then, if all of that happens, then these 2 line segments are congruent. And congruent, of course, means equal, and then we can set them equal to each other and solve. The converse is also true, meaning, forwards and backwards. And it says that if these are marked equal, then you know that you could cut this in half and have 2 equal angles. It's a lot of words, but it's not that hard to apply, actually. It's pretty simple. Okay, so we're going to do an example, and it says, out of the diagram on the right, what is the length of line segment QR? So they're asking for how long is this side of the triangle. And what we have to do is we have to look at the diagram itself. Notice that it has a perpendicular bisector. We know it's perpendicular because it creates the 90-degree angle. We know it's a bisector because it creates 2 congruent line segments. And when both of those things happen, then what we can conclude is that these 2 are also congruent. So what we're going to say is 3n minus 1 must be equal to 5n minus 7 because of the theorem. So that's this one right here. Because those 2 things have happened, then we can conclude that these 2 sides are the same. And then we just solve like normal. I'm going to subtract the 3n from both sides. And these go away, and I get -1 equals 2n minus 7. Then I'm going to add 7, and I'm going to run out of room. And I'm going to get 6 equals 2n, which would mean that n is 3. Okay, but they didn't ask us for n. They asked us for the measure of QR. So what we have to do is we have to plug in n, 3 for n right here. So 5 times 3 minus 7. Well, 5 times 3 is 15, and 15 minus 7 is 8. So this line segment must be 8. And if that's 8, so is this 8. Okay, in this diagram, we have an angle bisector, and we have two perpendicular line segments. So this is the second theorem that we went over. And what we can conclude is because it bisects the angle here, and because they're perpendicular here, we can conclude that these two line segments are congruent. And because they're congruent, we can set them equal to each other. So 6x plus 3 is going to be equal to 4x plus 9. And then we just solve like normal. I'm going to subtract 4x. And I get 2x plus 3 equals 9. I'm going to subtract 3. And I get 2x equals 6. And ironically, x equals 3 again, which is unusual, but that's okay. So x equals 3. But they didn't ask us for x. They asked us for the length of FB. So we have to plug 3 back in for x here. And so I'm just going to go ahead and do 6 times 3 plus 3. Well, 6 times 3 is 18. Plus 3 is 21. So what I know is that line segment FB is 21. And if it's 21, so is this one 21, because they are congruent. Okay, we're going to do this whole page together because I think it's a good practice for us to work these out together. Anytime that you feel like you can go ahead of me, just go ahead and pause the video and then work them out yourself. And then you can just fast forward the video and see what the answers are as much as you can. Otherwise, you can just work them out with me as we go along. It says, how is line segment WY related to line segment XZ? So WY is this line segment, and XZ is this one. And the relationship that they have is that they're perpendicular to each other. So we're just going to write the perpendicular symbol, which is an upside down T. And that's the only relationship they have. It says find XV, which is this little segment right here. But it's marked congruent to something else. It's marked congruent. I'm going to mark it here. It's marked congruent to this one. Well, that one's already marked to be 4. So it has to be 4. It can't be anything else because they're marked congruent. The next question says find WZ, which is this right here. And we're going to apply the theorem here that because of this perpendicular bisector, which we can see here, then what we know is that this line is congruent to this line. So if one of them is 7.5, so is the other one. These two have to be the same thing. The next thing says find XY, which is down here. Whoops. And again, if I turn the triangle, if you could turn your paper, don't forget what I said. If this is a 90-degree angle, so are all the other ones. So we have 4 90-degree angles here. And so now I can apply the theorem over here, that if I have perpendicular bisectors, and then these two are congruent as well. And if one of them is 9, so is the other one 9. And it says, what type of triangle is WXZ? So let's see, WXZ. Well, it has two congruent sides, so that means it's isosceles. Alright, I'm going to scroll down and we're going to do the next set. Okay, it says, use the figure at the right for exercises 6 through 10. Find the value of x. If you think you already know how to do this, go ahead and pause the video and do it by yourself. Otherwise, just watch. Because of the perpendicular bisector theorem, we know that these two are congruent. And when I say congruent, I mean like equal, same everything. So 3x plus 2 has got to be equal to 4x minus 3. So we're going to set that up and solve. Okay, so I'm going to subtract 3x from both sides. And I get 2 equals x minus 3. I'm going to add 3 to both sides. And I get that x is 5. So looking at the question, number 6 did ask me for x. So I've got that one. So it's definitely 5. X is 5. The next thing they ask me for is, what is the length of HI? Well, to figure that out, I'm going to have to use x equals 5 and plug it in to the expression. So 3 times 5, plus 2. Well, 3 times 5 is 15, plus 2 is 17. So HI is 17. Then they ask me for JI. Well, it has to be 17 as well, but we'll work it out anyway just to make sure. 4 times 5 minus 3. And that would be 20, because 4 times 5 is 20, minus 3 is 17. If you work them both out and you don't get the same answer, then you know you've done something wrong, because they should be equal, because that's how you solve for it. And it says, if L lies on line segment KI, then L is what from H and J? So they want us to create another point. Let's just make it here and call it L. Anything that lies on the perpendicular bisector is going to be equidistant from J and H. No matter where it is. We could put L anywhere, but no matter what, we could create another triangle, another isosceles triangle. And the fill in the blank, they're looking for equidistant, which means exactly what you think would be equally distant from from a point. What type of triangle is HIJ? And again, because it has two congruent sides, it's an isosceles. So that's going to be our answer. And we only have a little bit left to do. Maybe, I think. Okay. Again, if you think you know how to do this, go ahead and do it, and then check your answers. We got about 10 more problems left. It says, find the value of y. Using the angle bisector theorem, what we can conclude is that these two are going to be congruent. So we're going to have an equation that's going to be 6y equals 8y minus 7. And we're going to have to move the 8y because otherwise there won't be anything left over here. And we'll get negative 2y equals negative 7. And then we're going to divide by negative 2. And we get that y is 7 halves. Well, 7/2 is really 3.5, or 3.5 if you want to call it that. But either way, it's 3.5. Oops, if I could write a half. 3.5. It doesn't matter. I'm going to call it 3.5 just so I can, maybe put it in my calculator a little easier. So 3.5 is y. Then they want us to use that to find out PS and RS. And again, they should be the same answer, because if not, then we've messed something up. Okay, so if you, in your calculator, plug in, let's see, 8 times 3.5 minus 7, you should get 21. And if you take 6 times 3.5, you should get 21. So I know we've gotten it right. They're both equal, which is what they should be. And so the last question is, what type of triangle is PQS? PQS. PQS is a right triangle because it has a 90-degree angle here. And that's the answer. Alright, so the last one, I do want you to try to read it by yourself first so that you can see whether you would be able to answer these. The first question says, how is ray JP related to angle LJN? Yeah, LJN, it was hard to see. Well, here's what I know. The fact that it's marked congruent here, and we have these perpendicular segments, means that it's an angle bisector. Because that's what the theorem said, is it would have to be an angle bisector for that to happen. So ray JP is an angle bisector of angle LJN. And because it's an angle bisector, of course bisect means to break into two equal parts, then these two expressions are equal because these two angles are equal. So we're going to set that up and solve. So we have 5x equals 3x plus 18. And then, of course, we're just going to subtract 3x from both sides. And we get 2x equals 18, And then we divide by 2, and we get that x is 9. So that answers that question. Number 16's answer is 9. X is 9. But we then need to use that to figure out what each of the other angles are. And again, they should be the same thing. So when we plug in x is 9, we should get the same answer. So I'm going to give myself some space. And if I do 5 times 9, of course, that's 45. And if I do 3 times 9 plus 18, that's 27 plus 18, which is also 45. So those are 45-degree angles. And that's good because we wanted them to be the same. And anytime that you bisect a 90-degree angle, you're going to get 45 degrees. So we should have known that even before we started. But that's okay. MN, so they're looking for this. How long is this? Well, it's marked congruent to something else. So notice the marking here. And you can see that the other marking is up here with the 14. So that means it has to be 14. We don't know if it's centimeters or whatever, but whatever unit measure it is, it's 14. Number 20 is a different question. It says, write a conclusion about point M. There's a couple things you can say. Point M is equidistant from L and N. Because notice that they're 14 here and it's 14 here. So that means it's the same distance. So that's equidistant. So you could say that M is equidistant from L and N. You could also say that if you extended this ray, it would cut M and M would then be equidistant from K and O, which is also true. And rays do go on forever, so in theory this would extend through M. So either of those would be fine. And then 21 says, what type of triangle is JOP? Which is right here, and that would have to be a right angle. Well, right triangle. Okay, so we've done a good bit of exercises together, and now I want you to practice by yourself. So go ahead and try to do the practice page Form G, which looks like this. So make sure you can find it and then work those out. Ask if you have any questions. Use your notes if you need them, and your calculator.